So welcome to the next talk, Adaptive System with Architecture for Flow. So can you guess what these companies have in common? So that's more a rhetorical question. Well, these companies have in common that they don't exist anymore, or at least not with their original core business. All of these companies filed for bankruptcy or sold their core business. But why? What was the reason for these companies to file for bankruptcy or selling their businesses? So the major reasons were their failure to adapt. These companies failed to adapt or to keep up with new and changing circumstances, so that they were forced to file for bankruptcy or selling their core business, which led to massive job and financial losses, not only in the US, but also worldwide. These cases led to more than 200,000 job losses and 200,000 billions of US dollars of financial losses, such as creditor costs, lost revenue, and declining market shares. The failure to adapt led to a massive damaging impact on companies, on their employees, and their stakeholders. So the ancient Greek philosopher Heraclitus said, "The only thing that is constant is change." Maybe the change rate was slightly different when he made the statement 2,500 years ago. Looking only 20 years back, the change rates in the evolution cycles, they have rapidly increased due to the exponential pace of technology advancement. So in today's fast-paced environment, it's essential for the organization to continuously adapt and evolve to remain competitive and to stay relative in the market. So how to design now and build systems that are equipped for adapting easily and responding quickly to changing circumstances, and that can evolve and thrive in the face of constant changes. One approach is to tackle the situation from a rather holistic view and combining various perspectives. So it requires to understand the context-specific landscape an organization is operating and competing in. And it's also including understanding the external forces impacting the landscape, and in order to design effective business strategies. It also requires to gain domain knowledge and understand the business domain to build a system that is closely aligned to the business needs and to the business strategies. So it requires to align not only the technical solution, but also aligning the teams and evolving their interactions to the system we build and the strategy we plan. With other words, one approach could be by connecting the dots between Wardley Mapping, domain-driven design, and Team Topologies. So let's do this. Let's demonstrate this approach by using an example of an online school, an online school solution for junior students. And we can start with gaining a common understanding of the business landscape the online school is operating and competing in. And that's where we can start with a Wardley map. A Wardley map visualizes the landscape of an organization and is part of Wardley Mapping. And Wardley Mapping has been introduced by Simon Wardley, a researcher from the UK, and it helps you to design and evolve effective business strategies based on situation awareness and movement. So creating a Wardley map usually happens in a group discussion, and a Wardley map is composed of a y-axis and an x-axis. And to derive a value chain, it starts with identifying your users first, and your users could be your customers, your shareholders, your business partners, or your internal users. We are creating a few Wardley maps today. And we are going to focus on the teachers and the junior students as the users of our online school. Next is identifying the user needs, and the user needs are addressing the problems of our users in the subject area for which we build a product. And the teachers would like to create course content, they would like to plan a class, they want to help the students during their studies, and the students, they would like to studying the courses and requesting and receiving help, and also receiving evaluation feedback. And the users and the user needs, they are representing the anchor of the map that all subsequent components are going to relate to. Sorry, I have to get some water. Sorry. Or is it gin? I don't know. So next we are identifying then the components that fulfill the user needs directly or indirectly by facilitating other components in that value chain, and to determine their dependency and position in that value chain. So at the top we have those components where your users interacting with your system directly, and at the bottom it gets more and more invisible to the users. The teachers and students, they are interacting directly with the online school component that is at the top of our Wardley map, of our value chain. And this online component is depending on infrastructure components such as search engine, data storage, message broker, SMTP server running on top of within a cloud compute platform running on top of virtual machines. So they are less visible to the users and placed further down the value chain. Now, each of these components is going to be plotted along an evolution axis, going from left to right. So at the left, we have Genesis with brand new things, then custom build, then product and rental, such as off-the-shelf products or open source software solutions, and then things on the right like commodity and utility. And to determine the stage of evolution for each component, let's look at some characteristics of the evolution stages. Each evolution stage comes with different characteristics, and components evolve through the evolution stages, and as the components evolve, their characteristic changes. So from the uncharted domain on the left spectrum with an undefined market, where we are dealing with unknown unknowns, uncertainties, where we unpredictable, rare, poorly understood, chaotic domains. And while the components evolve through the evolution stages towards the right spectrum, it becomes more stable, more widespread, more industrialized, commonly understood, ordered. And we can use these characteristics to determine the stage of evolution for our components. So for example, the online school component, that's reflecting a volatile component, changing frequently, providing competitive advantage, and that shall go into the custom build evolution stage. And the infrastructure components are more stable, more widespread and mature. And at the current stage, we are using open source software solution for our infrastructure components. And so they shall go into the off-the-shelf, into the product and rental evolution stage. So this is our first iteration, very first iteration, and we can iterate later on onto that one. And we're using this map as a foundation for future discussion for architecture for flow. And the Wardley map provides a structured way to discuss and to generate a common understanding of the landscape, and also to discuss this in a group, and also challenge our assumptions in order to create a better map and to create a better understanding. And it also identifies areas where the organization can innovate or can improve efficiency or outsource to gain a competitive advantage. But that requires to understand the external forces that impact our landscape. That brings us to the climatic patterns. So climatic patterns are describing these external forces that are influencing our landscape over which we have no control. However, understanding these climatic patterns is important when anticipating change, according to Simon Wardley. So understanding climatic patterns gives us an idea where the landscape can change and where to invest. One pattern is that the landscape is never static but very dynamic. So everything evolves from left to right through the forces of supply and demand competition. So for example, cloud-hosted services reflect this climatic pattern. What was decades ago non-existent evolved through Genesis, custom build, became product and rental, and now it's available as utility services. Or large language models evolved thanks to the competition-driven technology advancement and became available as a product. And the standardization and industrialization of components that increases then our efficiency. That brings us to another climatic patterns of efficiency enables innovation. So the industrialization, standardization, and its efficient provision enables then the innovation of others. For example, it enables that new features of existing products can appear, or that other components can co-evolve, or that new components can emerge. And it's the genesis of new components enabling new user needs, creating future source of value as another climatic pattern. So understanding the landscape and the climatic patterns acting on it helps us to anticipate opportunities from a business strategic point of view, and gives us an idea of points of potential change and where to invest to gain competitive advantage. But before applying those changes and directly going into strategic actions, we need to assess how well we are equipped as an organization to respond to those changes quickly and absorb those changes gracefully. For example, to assess the responsiveness of change, we need to assess how a change would flow through our system. And we could assess what components are entangled in that change and how these entangled components are coupled. For example, we would like to introduce a functional change and add a new feature that serves then the course content creation user need. So that requires to change the business logic in the online school component. And currently, the online school component is a monolithic big ball of mud with a messy model and no clear boundaries. And it is impossible to modify just one part of the system, of this component, without impacting others. So we are dealing with tight change coupling. And due to tight change coupling, that the extensibility and the responsiveness of change, of functional change, is very low. And since Conway's law, we know that we have to consider not only the technical part of the technical solution, but also the socio-related part of the team organizations. So the teams of our online school are currently organized as functional silo teams. Introducing a functional change from front end to back end requires communication and coordination between multiple teams. So, for example, it requires the UI teams making front end related changes and hand over their changes then to the back end teams that are then adjusting the business logic for the functional change in the online school component, and hand it over then to the infrastructure teams to make changes to the database schema or to the search engine index or to the message format of the message broker. So, and due to handover, and the functional silo teams have to deal with high communication and coordination bandwidth between the teams when implementing and releasing changes. And blocking dependencies and high communication and coordination between teams slows down our software delivery performance and also our responsiveness to change. In addition, the big ball of mud with this messy model and the no clear boundaries, that leads to high team cognitive load and a lack of clear ownerships. So, and if the team cognitive load is largely exceeded, it becomes a delivery bottleneck, impeding also our responsiveness to change. We can also complement our assessment with how far we have applied Wardley's doctrinal principles. And Simon Wardley has created a collection of roughly 40 different doctrinal principles. We go through every one of it. No, just a joke. So we just we just want to highlight that he has created some principles that enables organization to respond to changes quickly and absorb changes gracefully. So when applying domain-driven design and team topologies, that helps us to automatically apply some of the Wardley's doctrinal principles out of the box. So, assessing our responsiveness to change at this stage, our system currently, with this tightly coupled monolith, with tightly coupled functional silo teams with handover, we are poorly equipped to respond to changes and poorly equipped to adapt to changing circumstances. How to change that? Well, to increase the responsiveness of change, we need to design and build adaptive socio-technical systems that are optimized for fast flow of change. And this could be achieved as one approach out of many by combining Wardley Mapping, domain-driven design, and team topologies. So we can use our previously created Wardley map as a foundation for our architecture for flow. Optimizing a system for a fast flow of change needs to requires to know where the most important changes in our system occur, the streams of changes. And the streams of changes, their types can vary for every organization. So they can go from role, task, activity, geography, customer segment related streams of changes. And we are focusing on the activity streams of changes reflected by the user needs. So the user needs of creating course content, planning a class, helping students, and so on. These are indicating suitable streams of changes, and they need to be focused on when optimizing for flow. And the users and the user needs, they are not only representing the anchor of our Wardley map, but also constituting the problem domain. And that brings us to domain-driven design. So domain-driven design helps us to gain domain knowledge of our problem domain. And usually a problem domain is composed of several parts, the subdomains, but not all subdomains are equal. Some are more valuable to the business than others, so we have different types of subdomains. So the core domain, that is the essential part of our system providing competitive advantage. And that is the subdomain of our system that we have to strategically invest in most. And buying or outsourcing this part would jeopardize our business success. Instead, we have to focus on custom building the core domains in-house. So the user needs of creating course content, planning a class, learning support, and studying courses, they fall into the resort of the core domain. They provide competitive advantage and leading to a high level of differentiation. The supporting subdomains, they help to support the core domain. They provide no competitive advantage, and we should, but are necessary for the organization to succeed. So we should look out for using or buying off-the-shelf products or outsourcing to using or buying off-the-shelf products for these supporting subdomains. If this is not possible, if we, for example, need a high level of customization or high level of specialization, then we can also custom build the supporting subdomains, but we have to be aware that we should not invest so much into that systems and this part of the systems because the supporting subdomains do not provide competitive advantage. And the generic subdomains are subdomains that many business systems have, like payment, authentication, and so on. So they aren't core, they provide no competitive advantage, but without the generic subdomains, our businesses would not work correctly. So buying or using off-the-shelf products or outsourcing to utility suppliers should be applied to the generic subdomains. So in our case, the user needs of signing in and signing up embody user needs of a generic subdomain. And many businesses need authentication and registration, so they are not core and provide no competitive advantage. But without registration and authentication, our online school would not work securely. So the subdomain types help us to prioritize the strategic investment and also support us with build, buy, and outsource decisions. But the solution of the subdomains are currently all mingled together in our monolithic big ball of mud with its wonderful messy model and no clear boundaries. And to be responsive to change, the architecture of our online school component needs to leverage modularity with high functional cohesion and loose coupling. So we need to decompose our online school component into modular bounded context from domain-driven design as one example. And a bounded context groups related business behavior together. A bounded context also forms a boundary around a domain model and defines where a single domain model can be applied and represents a unit of purpose, mastery, and autonomy. And bounded contexts, they are good candidates to good themes to split a system apart, but they also serve very well, they also provide different types of boundary, and for example, they serve very well as ownership boundary. We address this, coming back to that one in a second. So in designing bounded context and domain models involves a close collaboration between the domain experts and development teams, and there are various techniques available, such as event storming or domain storytelling, user story mapping, example mapping, and so on. So in this example, we have already done this collaboration, and we have designed the bounded context of content creation, of class management, course studies, learning support, and they fulfill the core domain-related user needs. So, and they are strategically important and require the most development efforts. So they go into the custom-built evolution stage and are going to be built in-house. The bounded context of student evaluation and notification handling, they belong to a supporting subdomain. So there might exist solution on the market already. However, the teams decided not to use the existing solutions, but because a higher level of specialization is needed, and they decided to build them in-house, but with the awareness that they should not invest too much into that part. The identity and access management bounded context belongs to a generic subdomain. There exist several solutions on the market already, and it should go either into product and rental or commodity and utility. And next is, or one step could be to find suitable team boundaries. And as I mentioned earlier, the bounded contexts serve very well as ownership boundaries, forming a unit of purpose, mastery, and autonomy. And so the bounded context indicating to good seems to split our system apart, but also work as suitable team boundaries for stream-aligned teams, and that's where we come to team topologies. The stream-aligned teams were introduced by Matthew Skelton and Manuel Paich in the book Team Topologies. And stream-aligned teams, they are autonomous cross-functional teams that are aligned to a continuous stream of work and focusing on a fast flow of changes. But to be able to focus on a fast flow of changes, to be able to produce a steady flow of feature deliveries, they need the support from other team types, for example, from the platform teams. And the platform teams, they support the stream-aligned teams delivering their work and are responsible for platforms that the stream-aligned teams can easily consume. And the platform can vary in its level of abstraction. So at a lower level, a platform can abstract away infrastructure, networking, cross-cutting capabilities. And at a higher level, it can also abstract the design system, a data platform, machine learning, and so on. So in the platform teams, they provide internal self-service services and tools for using that platform that they are responsible for. All these stream-aligned teams can get support from the enabling team that have kind of like coaching role in the organization, and the enabling team help to identify and acquire missing capabilities. Or the stream-aligned teams can get support from the complicated subsystem teams. That's an optional team type. They are supporting the stream-aligned teams on particularly complicated subsystems that require very specialized knowledge. And all of these teams, they have the focus, or their goal is to increase the autonomy and to reduce the cognitive load of the stream-aligned teams. To arrange these teams in this team type is not enough to become effective. How these teams are interacting with each other and when to change and evolve the interaction between teams is also very relevant for organizational effectiveness. So, for example, with collaboration, teams are working very closely together over a limited period of time, and this is suitable for rapid discovery and innovation, for example, when exploring new technologies. So, collaboration is meant to short-live. So then we have X as a service. That suits well when one team would need a component, a code library, an API or platform that can be effectively provided by another team as a service. And that works best where predictable delivery is needed. Then facilitation, that is the interaction mode when one team would benefit from active help from another team, like a kind of like internal coaching. And this is very, an interaction mode is very typical for the enabling teams. So as mentioned previously, coming back to our Wardley map, the bounded contexts are serve well as well-defined ownership boundaries for our stream-aligned teams. And as I said, streamlined teams, they are relying on other teams supporting them, delivering their work so that they can focus on fast flow of changes. And that requires to identify services that are needed to support a reliable flow of changes that can form an easily consumable X as a service or platform as a service. So in our example, the infrastructure-related components of our Wardley map located in product and rental or commodity and utility, they are potential capabilities forming a platform that can be effectively provided as a service by a platform team. So this previous consideration might result into this illustrated team constellation as just a very first draft. So the 4 core domain related bounded contexts residing in custom build, they are going to be split among 3 streamlined teams. The supporting and generics subdomains, they are going to be handled by another streamlined team, and the infrastructure components are going to be handled by 1 or more platform teams. Another aspect that we need to consider, and also for our responsiveness to change, is to mind potential efficiency gaps. So from the climatic patterns, we have learned earlier that everything evolves through the forces of demand and supply competition. And so if the evolution stages of the components we use internally in our organization differ from the ones available in the market, that might indicate an efficiency gap. So for example, if we are custom building components in-house and an equivalent component is available in the market as commodity, that indicates an efficiency gap. So we are lagging behind the evolution of the available components in the market. And closing that efficiency gap would then increase our efficiency. And as we have learned earlier from the climatic patterns, efficiency enables innovation. So one approach of closing this efficiency gap could be done, for example, by migrating our on-premises infrastructure components to cloud services that we are addressing in a second. So at this moment, we have not transitioned anything yet. We did just prior architecture and design consideration and team constellations. Now, how to transition to the target architecture for flow. And this transition can be led by dynamic reteaming and an evolution of team topologies and the evolution of team topologies interaction modes. We could start closing the efficiency gap, for example, with replatforming, one of the 6 cloud migration strategies, where we replace the on-premise infrastructure components with cloud-hosted services while we keep the application's architecture the same at the moment. And this can be, for replatforming, we are forming then our first platform team from members of the previous backend and infrastructure teams. And this new platform team can work at the site, having the liberty to discover and explore cloud technologies, and they can focusing on incrementally replacing the on-premise infrastructure components with cloud-hosted services. Once the infrastructure components have been fully replaced with cloud-hosted services, the previous infrastructure team can then merge into the new platform team and can split later into separate platform teams. And from there, the first streamlined team can form from members of the previous front-end and back-end teams. And this first streamlined team can then kick off the refactoring journey. And with refactoring, we are breaking down the application's architecture into smaller parts. In our example, we would like to decompose our monolithic big ball of mud into the previously designed bounded contexts. And the streamlined team can then work closely together with the platform team. So the refactoring journey of our streamlined teams is supported by an evolution of team topologies interaction modes. So the streamlined team can closely collaborate with the platform team, assess potential cloud options for the future bounded context that the streamlined team is responsible for. And So the Streamline team might decide to refactor their bounded context using serverless technologies. And as soon as the potential cloud options have been discovered together with the platform team and the knowledge has been shared among them, the interaction can go then into limited collaboration, and this evolves then to X as a service once the serverless ecosystem is more established, where the platform team then can provide best practices, standards, tools, APIs to easily consume the cloud services. And the next Streamline team can then form and go on their refactoring journey and receive them active help in the facilitation interaction mode during its cloud journey. And so, for example, the platform team can coach the second Streamline teams about applicable cloud options that they can use for the bounded context, or they can also coach them how to use these new CI/CD pipeline in the serverless ecosystem. Or the first Streamline team can also coach the new Streamline team, sharing their knowledge for what they did gain with their refactoring, and can also coach them about best practices, how, for example, how to implement serverless function in a hexagonal architecture. So, and this can then evolve later, and this team topology interaction modes can evolve later. And once the new Streamline team becomes self-sufficient, the interaction modes can then change into X as a service with the platform team. And then from there on, rinse and repeat, the next Streamline team can go on their refactoring journey, so that at the end we are able to refactor our monolithic big ball of mud, decompose it into modular bounded context with foremost Streamline teams, and have also and platform teams, and have optimized our original system for fast flow of change. And we can also derive different Wardley maps as well, or value chains. For example, we can switch to the platform team perspective. Not only that we are, well, then the internal users are, or where the Streamline teams become then the internal users of the services that the platform teams provide. And for example, the Streamline teams have then the user needs of building and testing, releasing and deploying, operating, monitoring the service of bounded context they are responsible for, and also provision the infrastructure for their services. And to fulfill those user needs, the platform team can provide a variety of X as a services. For example, they can provide a pipeline as a service to support the Streamline teams to build, test, release, and deploy their services. And this is built then on top of other components. Or to operate and monitor services, the Streamline team require dashboards or alert mechanisms, observability capabilities, such as log management, metrics handling, distributed tracing, and these capabilities can be provided by the platform team as monitoring as a service. Platform as a service enables then the Streamline teams to provision the runtime environment for the services, including the necessary components that services rely on during runtime, such as database, search engine, message broker. And that we also might to identify some capability gaps, and that's where the enabling teams come into the scene. And when we are blending the enabling teams into the value chain, there we switch also having then the Streamline teams and the platform teams as their internal users, and where the enabling team can facilitate or support the Streamline teams and platforms to identify and acquire missing capabilities, and have internal coaching capabilities in various aspects that the Streamline teams and platform teams have to cover. You can also say, you might object saying, but we are successful. Why should we do so much investment? Why the heck shall we change? And that's fine, as long as you have no competition. So all your competitors are less evolved. And that's where another climatic patterns comes into the scene. Inertia to change created by past success is impeding the evolution of components. And the inertia to change increases the more successful the past model is. And it's not the lack of innovation that can kill an organization, but their inertia to change. For example, Nokia was very innovative. They invented their first smartphone in 2005. That was 2 years before Apple came out with their first iPhone. But still, Nokia was at that time so successful with their old cell phone model that they were very reluctant to fully transition to the smartphone era. So within 6 years, their market share dropped by over 90%. So being successful today doesn't mean you stay successful tomorrow, and when the world around you changes. And when the market changes, you have to change too. So investing in building adaptive socio-technical systems optimized for fast flow of change equips you to thrive in the face of constant changes. And we are now in a position where we are not only able to respond to changes, but also leading future changes. And we are now in a position to impact the landscape to our benefit by deciding and applying strategic actions. For example, by creating additional differentiation value to increase our competitive advantage, or by being the first mover to commoditize components that others can innovate on, or by building or cooperations and alliances to accelerate the evolution of components and grow also our ecosystem. Now, we are in the driving seat of change. And this brings us to the key takeaways. I get this slight change signed from the side that I should shut up. So the combination of Wardley Mapping, domain-driven design, Team Topologies helps us with understanding the landscape an organization is operating and competing in, and including understand the external forces that acting on the landscape. It helps us to anticipate changes. It helps us to gain domain knowledge and discovering our core domain, providing competitive advantage. It helps us to make buy, build, or outsource decision. It helps us to leverage modularity with bounded contexts and also serving as well-defined ownership boundaries. It helps us to align in, our teams involving their interaction to the system we build and the strategy plan. It helps us to identify potential efficiency gap and eliminate delivery bottlenecks. So the combination of Wardley Mapping, domain-driven design, and Team Topologies provides a holistic tool set to optimize for fast flow of change, to be able to adapt and evolve and thrive in the face of constant change. And with that one, yeah, by the way, there's also a book coming out. I thank you.
Thank you very much, Susanne.
And are there some questions? Sorry,
there are plenty of questions, but we cannot answer all of them, I think. But speaking of the book, one question was, and I'm just a messenger here.
Yes.
Keep that in mind. When will it be published?
Vaughn? Where's Vaughn? Yeah, I hope this year. Does it?
Okay.
I'm still working on it. I'm not giving up. But it's like really stressful currently. But I'm incorporating feedbacks and.
Apparently, Amazon does not have faith in you because they say it will be published in 2024.
Is it already? Oh, they know more than me. They have created some Wardley maps maybe and have absorbed my responsiveness to change.
Okay. Then we have a question by Andy. Team Topologies is nice, but what do you do if the monolith is huge and there is only a 6-people team? Oh. Does it still make sense?
Well, so that is amazing, first of all, that you can manage this huge monolith with only 6 people. So I would suggest, like, for example, I used to be a startup CTO. We were a little bit larger, but we had encountered this challenge only to being small teams. And I would encourage that try to identify your flow of changes and where are your bottlenecks in your system. So, and that you, for example, that you can then form task forces rather than separate teams, for example, for the platform as a service to provision your infrastructure that the other teams or the other team members can easily consume. So that at least we have some, maybe not separate teams, but maybe task forces where we have this X as a service within your team.
Okay, yeah, that makes sense. One final question. there might be a little bit of a misunderstanding in the question, but you'll tell us if I'm correct. Again, from Jean or Jean. Conway's law states that the structure of any system is isomorphic to the structure of the organization. To change the system structure, do you begin to change the organization, or to change the system, or both at the same time?
Inverse converse maneuver, maybe. So yeah, it was since we are incrementally. We are starting. So in my example, I described it as a team-first approach. So I starting with forming, or in combination with dynamic reteaming, starting incrementally with forming some teams first, and so it's more like an organizational approach first, and then they can start on their, for example, bounded context they are responsible for.
Okay.
I don't know if I've answered that one. Please, otherwise, post this question to me as well. So I also have a Twitter handle.
Great. Thank you very much,
Thank
Susanne.
you.